Right, number one, find the first 5 terms of the sequence. A sub n equals negative 1 to the n times n plus 1 over n plus 3. So we basically just need to plug in 1 and then 2 and then 3 and then 4 and then 5. So I'm going to do that. I'll get negative 1 to the first times 1 plus 1 over 1 plus 3. Negative 1 to the first will be negative, and then that will end up being 2/4, which would reduce to negative 1/2. Second term, I'll just plug in 2. Get 2 plus 1 over 2 plus 3. Negative 1 squared will give me a positive, and that will give me 3/5. So that's my second term. My third term, we'll just plug in 3. So 3 plus 1 over 3 plus 3. Negative 1 to the third power is a negative, and then 3 plus 1 is 4 over 6. That will reduce to 2/3. And then the fourth term, we'll just plug in 4. So 4 plus 1 over 4 plus 3. Negative 1 to the fourth power is a positive answer, and then 4 plus 1 is 5 over 4 plus 3 is 7. And then a sub 5, we'll just plug in 5. And so negative 1 to the fifth will be a negative number. 5 plus 1 is 6 over 8, and that reduces to negative 3/4. So these would be my first 5 terms of the sequence. Number 2, determine if the sequence converges or diverges. If it converges, find the limit. So if we want to find if something is converging or diverges, we definitely want to find the limit as our n approaches infinity. And my sequence is 2 over n plus 3 to the n. So I'm just going to be thinking if I plug infinity in for my n's. So 2 divided by infinity, as the denominator gets bigger and bigger, that will approach 0. And then plus 3 to the infinity, especially since we have 3, this would be an exponential growth. 3 times 3 times 3 times 3 times 3 is going to be a larger and larger number, so that actually is going to approach infinity, and 0 plus infinity is infinity, which means the sequence diverges. Just to know, if this number would have been like 1/2 instead of 3, if I do 1/2 times 1/2 times 1/2 times 1/2, that actually would have approached 0. So we just want to keep in mind, what is that value? Number 3, determine if the sequence converges or diverges. If it converges, find the limit. So again, we want to find out if it converges or diverges, we actually do want to try to find the limit. 4n squared plus 1 over 2 minus 3n squared. First thing that we want to try to do is plug in infinity, and if I do that, I'll get infinity in the numerator and I'll get negative infinity in the denominator. That gives me an indeterminate form, so I actually can use L'Hopital's on this. So I'm going to get the limit as n approaches infinity. If I take the derivative of the numerator, I'll get 8n. If I take the derivative of the denominator, I'll get negative 6n. If I go to plug infinity in, I'll get infinity over negative infinity. So once again, I can use L'Hopital's rule. So the limit as n approaches infinity of derivatives, again, 8 over negative 6. So that pretty much gives me where I need to be. That reduces to negative 4/3. So I actually found a limit, and if I found a limit, that does mean that my sequence converges. And it did say, does it converge and then give the limit? My limit is negative 4/3. Okay, number 4, find the limit of the sequence a sub n equals 1 plus negative 1 to the n all over n using the sandwich theorem, or we can also call that, of course, the squeeze theorem. All right, so we want to try to find out a function that's smaller than this one and a function that's bigger than this one. The biggest thing on this one, negative 1 to the n, it's always going to toggle back between negative 1, 1, negative 1, 1. So the smallest this answer is ever going to be is negative 1. So if I take negative 1 plus the 1 that's already there, the smallest the numerator is ever going to be is 0. And we'll just keep the denominator. And then the biggest that negative 1 to the n will ever be is 1, and 1 plus 1 is 2. So the biggest the numerator will ever be is 2, and we'll still put it over n, which means I'm sandwiching that sequence in between my 2 other sequences. So we know that 1 plus negative 1 to the n over n will always give me an answer between 0 over n and 2 over n. So now using the sandwich theorem, we're going to find the limit of both of my n's. So if I approach infinity, 0 divided by infinity is 0. So that limit is 0. I'm going to find the limit of my right endpoint. As n approaches infinity, I'll get 2 over infinity. That will also give me 0. All right, so since we found out the limit on each end is equal to 0 due to the sandwich theorem, we can also then say, I'm just going to put a therefore, that's my fancy therefore symbol, the limit as n approaches infinity of 1 plus negative 1 to the n all over n must also equal 0. And that would be due to the sandwich